Hello. Before we begin our work in trigonometry, or chapter 7, we're going to take a little bit of time to review some skills that you probably already know, but we want to make sure that we have a good handle on, and that's our Pythagorean Theorem. So most students, when I ask, what's the Pythagorean Theorem? You can tell me that's a squared plus b squared equals c squared. But what we want to know is exactly how that's used and how it helps us solve applications. So when you're using Pythagorean theorem, or a squared plus b squared equals c squared, you have to have a right triangle, and you're wanting to solve for one of the side lengths. Okay, does it matter which one that is? We just want to solve for a side length. Now, it's always important that you check. It has to be a right triangle. We want to identify that right angle in the right triangle right away. And then we want to make sure that if we have application problems or word problems, we can set those up accurately and use that Pythagorean theorem to our advantage. Pythagorean theorem is going to continue to kind of pop up, not just in chapter 7, but throughout the rest of this course. So we just want to take a little bit of time to review these skills. So let's go ahead and share some notes here so that we can go over that and look at a few things this way. All right. So again, if we were wanting to solve for the side length of a right triangle, we're going to use Pythagorean theorem. Okay, a squared plus b squared equals c squared. But good idea to make sure that we understand what those side lengths represent. Okay, so in a right triangle, what you have are the two sides of the right angle, which are called the legs. And then directly across your triangle from the right angle is the hypotenuse. The hypotenuse has to be the longest side, okay, of your right triangle. Okay, has to be. The 90-degree angle is the largest angle, so then the hypotenuse straight across is going to be the largest side in our triangle. So always make sure, okay, that the equation is set equal to the hypotenuse squared up here. Okay, A and B are the two legs. It doesn't matter which one you call A and which one you call B. Okay, but this could be like a squared plus b squared equals c squared when we're setting this up into Pythagorean theorem. So let's just look at solving a couple problems here and working this out. So if I were to look at this triangle, right away we see the right angle. So we have a right triangle. So the two sides of that right triangle are the legs. So this would be 4 squared plus 6 squared equal to the hypotenuse. And I should recognize that the hypotenuse is directly across from that right angle. So here it's labeled x. So we're going to make this equal to x squared. Make sure you're dealing with these exponents accurately. 4 squared is 4 times 4, or 16, plus 6 squared, which is going to be 36. And we'd want to take the sum of these two values here. So we're going to take 16 plus 36 and get a value of 52. Now, algebraically, when I'm solving this equation, I want to be able to cancel out this square. So I'm going to square root both sides of the equation. I don't need to put a plus or minus sign here because x is a length on my diagram, so it's going to have to be positive. So we will get x equal to the square root of 52. Now, in most cases, the problem's going to have you round this off to a decimal of some kind. So we'd want to enter this in here as the square root of 52. And we're going to get a decimal value here. We'll approximate this right now to the nearest hundredth. So then that will give me a value of 7.21 approximately. Okay, in some cases, and when you take your standardized test, possibly like ACT, they might have you simplify this radical and keep it as an exact value. So I just want to kind of show that being broken down. 52 does have a perfect square factor. So we could factor 52 into 4 times 13. So if I were to simplify the square root of 4 is 2, and then 13 stays underneath my square root. So as an exact answer, it would be 2 root 13. And if you multiply this together again, it would give you this decimal, 7.21. In today's assignment, when we're practicing with this, we are going to have you rounding that answer off to a decimal. So that will be fine. All right, so let's look at the second one here. Be careful. Again, we do have a right triangle, so we can use Pythagorean theorem to solve for a length. And I should notice that the two legs are 3 and x. So I've got 3 squared plus x squared equal to the hypotenuse, which is directly across from my right angle, 7 squared. So now I've got 9 plus x squared equal to 49. So I'll subtract 9 from each side, and x squared would be equal to 40. If I want to cancel out my square, I square root both sides, so we've got x equals the square root of 40. So if I were to round that off to a decimal again, the square root of 40 would give me an approximate value of 6.32, okay, if I round to the nearest hundredth. Okay, or again, as an exact value, 40 would factor to 4 times 10. So we would get the square root of 4 is 2. 10 stays underneath. So we get 2 root 10, okay, as a value. All right, now in some cases, when we work out Pythagorean theorem with our right triangle, we get an actual integer answer for each of my side lengths. So for instance, in this problem here, if I were to solve for x, I should notice that x and 12 are the legs, and 13 is my hypotenuse. So I have x squared plus 12 squared equals 13 squared. The 12 squared is 144. 13 squared is 169. So if I subtract 144 from each side, I get 25. We square root, we get the square root of 25, which is a perfect square, or 5. So then in this case, my side length is exactly 5. It doesn't happen very often, but sometimes you get 3 integer values on your right triangle. Okay, these are special types of values called Pythagorean triples. And mathematicians like to use these. Okay, within application problems, you see them within construction and other applications because they're ones that work out to integer values. So if we do see that you have a Pythagorean triple, you have to have a set of 3 positive integers that are side lengths of a right triangle. The one we just used here was a 5, 12, 13. Probably the most common you see come up in problems is the 3, 4, 5 triangle. But here are 2 other common ones, 7, 24, 25, or 8, 15, 17. If you recognize these, then you don't even have to plug into Pythagorean theorem to solve. You just know you have your Pythagorean triple. Please keep in mind with these that also multiples of these values will always work perfectly in Pythagorean theorem. Okay, so for instance, if I had the Pythagorean triple 3, 4, 5, I could multiply each of these values by 2 and get 6, 8, and 10. Okay, so 6, 8, 10 would also be considered a Pythagorean triple. And again, if we plugged into Pythagorean theorem, 6 squared plus 8 squared would equal 10 squared, okay, or 36 plus 64 does equal 100 exactly. Okay, so you can see that this would make Pythagorean theorem equal. So these are definitely values of a right triangle, and then since they are all integers, they would be a Pythagorean triple. Now, here's one question that kind of comes up every now and then. We might want to know, are these three values sides of a right triangle? Could they be used to create a right triangle? Well, what we could do is test out, okay, those lengths within our problem. So in this case, we have 8 squared plus 14 squared equal to 16 squared. I know that I would need to test 16 as my hypotenuse because it's the largest side. So then 8 squared gives us 64, 14 squared 196, and 16 squared 256. If I add these together, I get 260, which is not quite equal to 256. So if it doesn't work out perfectly in Pythagorean theorem, then this is not a right triangle. Okay, so just kind of careful that way. Now, most of what we want to do, okay, with our problems is be able to apply Pythagorean theorem to some applications. So I'm just going to work out a couple of these word problems here to see if you could set these up and apply your Pythagorean theorem. Okay, so in number 1, we have Carl walked 4 meters west. So just kind of pick a starting point here. Okay, 4 meters directly west, okay, would be in this direction. Okay, so I could label that as 4 units. And then from here, we're moving 5 meters south. Okay, so then here. Now we should recognize if we move perfectly west and then south, that is going to make a right angle. And we want to calculate how far he is from the actual starting point that I placed here. So that would make a right triangle for me, and I could label that as x. So what I can see is the calculation that I need to make is the hypotenuse. So if I plug this into Pythagorean theorem, it should be 4 squared plus 5 squared equal to x squared. 4 squared is 16, 5 squared 25, and equal to x squared. If we add those, we get a sum of 41. So x will equal the square root of 41. Okay, again, that's not a perfect square, so this isn't going to work out evenly to an integer. So I'll plug this in to round it off. The square root of 41 would give me an approximate value here of about 6.40, because we're rounding 2 decimal places in this case. And then this should be labeled in meters. And then I think the second part of your question here said, state whether this will be a Pythagorean triple. Well, since this was not an integer value, then that would not be considered a Pythagorean triple when I went to work that out. All right, if we look at this second one, again, look to see how we can draw that right triangle, okay, to match or follow this application. So Martha's house is 20 meters long and 18 meters wide. Okay, so if we look at the length of this, okay, you kind of got a house here, but we'll just make it rectangular. Okay, 20 meters in length and 18 meters wide. How long is the diagonal of the house? So the diagonal then could connect to these vertices. And again, that would make this rectangular. And then, again, I would be solving for hypotenuse. So we've got 18 squared plus 20 squared equal to x squared. So 18 squared gives me a value of 324. 20 squared, 400. So this would be 724 for x squared. So we get the square root of 724. Now, not sure if that's a perfect square, so let's test that. Okay, the square root of 724 gives us a value of approximately 26.91. Again, did not work out evenly, so this is not going to create a Pythagorean triple. All right. In number 3, here we have a ladder that is standing on horizontal ground and rests against a vertical wall. So you've got the wall of the building here, and then here's your ground, and then your ladder would be resting on that. So that would be the hypotenuse. The ladder is 5.5 meters in length. So I can put that on the hypotenuse. And its foot, okay, so the bottom of the ladder is 3 feet from the wall. Okay, so I have 3 labeled there on the base of that right triangle. And we want to calculate how far up the wall the ladder will reach. So we're really solving for the height. Okay, where does that ladder, okay, attach to the wall? Again, this will be a right triangle in here. And because it's a right triangle, Pythagorean theorem would be appropriate. So I could use h squared plus 3 squared equal to 5.5 squared. So h squared plus 9 equal to, and then when I take 5.5 and square it, I get 30.25. Okay, don't round anything off in the middle of your problem. Okay, wait until you get to the end. So now I'm going to subtract 9 from both sides, and I've got 21.25. And then the square root of that value would give me approximately 4.61. And again, what would be my units of measure here again would be in meters. These have all been in meters. Okay, so far. Okay, so then we've got our height in that case. Okay, keep in mind here the ladder against the wall, that's kind of at your diagonal, that's your hypotenuse. And again, because it looks across from that 90-degree angle. All right, you will have some problems to kind of just practice Pythagorean theorem, okay, and especially kind of working with these applications to make sure you can work them out correctly. Good luck with this assignment.